pinion starter motor is a powerful electric motor used for cranking an engine. The starter motor has a pinion, which meshes with the teeth on the flywheel of the engine and turns the crankshaft. The model shown here is a pre-engaged type starter motor used in modern vehicles. It uses an electric motor to provide torque to the crankshaft. The power for this motor can be drawn from the battery. A simplified circuit of power supply is shown here. The power from the battery is supplied to a solenoid. An ignition switch is installed between the battery and the solenoid to turn the power on and off. The solenoid is an electromagnet which requires small current to get energized. As the ignition switch is turned on, the solenoid gets energized. A moving core known as a plunger slides along the coil, which connects two copper terminals of a contactor switch. This completes the circuit from the battery to the motor and causes the rotor to spin. When the solenoid is de-energized, the core returns back and disconnects the motor from the battery. We may wonder why the solenoid and the contactor are used instead of directly connecting the battery to the motor and reducing the complexity. The reason behind not using this circuit is the high current demand of the motor. The motor is considerably powerful and demands heavy current for operation. To handle this current, the ignition switch needs to be unusually large. It also requires very thick wires running from the battery to the switch and then to the motor, which is technically inconvenient. This is why solenoid is used, which demands lower current for being energized. The solenoid has another crucial function. It helps to slide the pinion and engage it with a flywheel before the motor starts to spin. As the pinion slides towards the flywheel, it slightly rotates on its axis, as shown here. This rotation is achieved by using a helical spline. This rotation helps meshing the pinion with the flywheel more conveniently. As the pinion and flywheel is properly meshed, the contactor switch gets closed, and the motor spins. As we can observe that the pinion is considerably small compared to the flywheel, the gear ratio of the flywheel and pinion is generally from 15:1 to 20:1. The high torque obtained from this gear reduction is still insufficient to crank the engine. So, a planetary gear set is introduced to increase the torque further. Planetary gears are incredibly useful for large gear reductions with less weight and limited space. It consists of a sun gear, a ring gear, a carrier, and a set of planet gears. In starters, the ring gear is fixed, the sun gear is the input, and the planet carrier is the output. For the setup shown here, the gear ratio is 7:1. The combined gear reduction results in enough torque to spin the engine. As the engine is started, the pinion needs to be disengaged from the flywheel to prevent backdrive of the motor, which might damage it due to the excessive speed. This is done by releasing the ignition switch, which de-energizes the solenoid and the pinion returns back. But if the operator fails to release the ignition switch as soon as the engine is started, the flywheel will drive the pinion too fast and damage the motor. To prevent this, a one-way clutch is used. The one-way clutch has a set of rollers installed between the outer and inner races. When the outer race is rotated by the motor, the rollers get trapped and transfer power to the pinion. As soon as the engine is started and drives the pinion at a high speed, the rollers get released and power transfer is stopped.